Okay, guys, I just want to do a bit of revision on the manufactured boards chapter from your textbook, and we just need to talk a little bit about them, and I'm giving you a question then to be answered. Okay, so first of all, manufactured boards, what are they? They are boards that are man-made, usually by processing timber or other timber products into a sheet, so sheet form. They're a substitute then for solid woods, and they have major and many disadvantages. Sorry, advantages. If we're using these timber products that would otherwise be wasted, such as timber particles, wood chips, and smaller wood sections, boards made of veneers, well, what do? They help to conserve trees and tropical forests. And man-made woods, manufactured boards provide large, flat pieces of stable wood with a uniform thickness, and they're used for worktops and bedroom and kitchen units, and they come in very, very handy. Okay, so just looking at some of them here. So what are they made from, or what can be used to make manufacture boards? Well, first of all, veneers. You can use sawdust, wood fibers are used, wood strips, wood flakes, and all of these come together in order to create these boards we have on the right hand side here. And these are just examples. This isn't all the type of manufactured boards you could have, but it is some. So blockboard is timber that is made by putting strips of timbers together, alternating the grain, or at least the annual rings, and putting a facing of veneer on each side just to make it look better. There's plywood. We're well used to plywood. We've used it a lot. Oriented strand board, chipboard, medium density fiberboard. They're all similar boards, but slightly different. In oriented strand board, you will see quite clearly the strands that are used to push it together. Chipboard, the strands or the strips or the fibers are a little bit smaller. MDF, it's almost sawdust, and hardboard, the same thing. Okay, sawdust, very fine pieces put together. What do we need to know? Well, we need to know what the properties of a manufactured board are. Why is it so useful? Well, first of all, they provide us with large and uniform sheets, even sheets, which have a uniform thickness. Okay, so unlike normal timber, which can be bent or twisted or warped, in general, our manufactured boards are good, stable, uniform, large sheets. They have a nice smooth surface. They are strong because of the way the grain is oriented. They had very few defects because we make them to not have defects, which makes them nice and easy to work with. It also makes them relatively cheap because a lot of them are using the timber that otherwise would have gone to waste. So therefore it's cheaper. And in order to make them look pretty, we can finish them with a decorative veneer, which will add to the look of the timber and look of the piece, but yet still include all these things that have gone before us here, where they are cheap and large and so on. And then they also reduce waste by using wood efficiently. So they're using other stuff that would otherwise go to waste. Okay, so that's the properties of manufactured boards. And it's also a list of things that we want to that are important in manufactured boards. Now, just to go back over those two slides for a minute before I go any further, and I just want to highlight the keywords here. Veneer is a keyword. Sawdust, well, we knew that. Wood fibers, keyword, key phrase. Wood strips, wood flakes, and blockboard. In fact, all of these are really plywood, oriented strand board, chipboard, MDF, and hardboard. Okay. Over here, defects is a keyword because we have few. Actually, I should write few defects in this case. We had the word defects anyway in our other chapters. Decorative veneer is a key word or key phrase. Bear in mind when I'm giving you a keyword or a key phrase, what I'm trying to do is highlight something that you will be able to use when answering a question. Uniform thickness is important. It's not something you would normally use in your everyday vernacular. Reduce waste is a key phrase. Properties is a key word. All right. So properties, uniform thickness. Moving on. All right, we're going straight away into talk about plywood. What is plywood? Plywood is it's like a sandwich. That's the way I like to think of it. It's a sandwich made up of layers of veneers. Okay, you may have 3-ply, 3-ply, 5-ply, 7-ply, 9-ply, all the odd numbers basically of plywoods. Why is it odd numbers? Because the top surface must have the same grain direction as the bottom surface. So hence why we always have an odd number. The arrows here show the direction of each layer, and if I was inside in a test, I would be drawing onto this drawing and showing that, look, the grain on this side is going in this direction. The grain here is going in this direction. In the next layer, we're back to horizontal grain. This section again, we're back to perpendicular grain to that angle. And then the final and fifth section, we're back going in this direction. And what is important is that the top one here and this bottom one here are both going in the same direction. So it's always, hang on now, back down here, always an odd number. Okay, so the veneers are at 90 degrees to each other. You can see that there, they're perpendicular, and yes, it's always an odd number, and there it is at the bottom anyway. Now, when veneer is cut using, or well, there's a few different methods, but here's one method. We usually use rotary cutting for this. So what happens is the sorry, no, 1 second, I just got a cutter. Here we go. So the log spins, so it's the very same as what we're using a lathe. And the log is spinning towards the knife, which is cutting into that log. And as it's cutting in, the knife is moving inwards, slowly but surely along that log in order to peel off this thin strip of veneer, usually about 2 millimeters thick, thereabouts, okay? And it's peeling it off, and it's getting this one continuous strip, okay? So you're getting a continuous strip of veneer. Now, there are other ways of cutting veneers as well, but for plywood manufacture, this is what we use. The other methods would be used when you are producing veneers for maybe decorative work. But for plywood, it goes in this direction. Okay, so in order to just go back over that, and again, thinking of good old keywords, veneers at 90 degrees is important to each other. Odd number is key phrase used again. You need to answer a question. And I don't see rotary cutting written in there anywhere, so I will write that in now. So this bit is important. It's rotary cutting, it's called. Okay, moving on then. What types of plywood might you have? We have WBP plywood. Now, learn this off. This often comes up in the exam. What does WBP stand for? Well, it stands for water and boil proof. Okay, and what does that basically mean? It's an exterior grade. It's for outside plywood. In other words, it'll withstand the weather. It'll withstand the rain. It'll withstand everything. And then going a step further again, we have marine plywood. And again, this is a key phrase. It does what it says in the tin. Something that's marine is for both buildings. So this is for even more exposed situations. It can be used in roofs as well. So again, it is waterproof. Okay, water and boil proof. That's just types of plywood. And nothing else needed there. No. Moving on. Blockboard then. Okay, so what is blockboard? So we've already had plywood, which was layers of veneers put on top of each other. Blockboard is literally blocks of timber that are butted together and glued in order to create this large sheet, and then they are faced. So in other words, the front is covered in a veneer, so it's faced in a veneer, and so is the back to make it look good. So there's strips of softwood glued together and faced with veneers. They do not split easily. You can screw them into the edge because they're nice and strong, and you can create very, very wide sheets, 8 foot by 4 foot sheets, which if you are familiar with the storeroom in school, when you go into the storeroom and you look to your left-hand side, you will see a number of large sheet material. They're all 8 foot by 4 foot, okay? One thing to note on this here, and I know I have mentioned this in school before, so I'll mention it here again now, is the direction of the blocks. So the annual rings are really important, and you should recognize this drawing, which is indicating that the annual rings must be placed opposite to each other for each layer. Okay, very, very important. Why? Because we do not want cupping. Oops, that's a terrible drawing. I'll try it again. We do not want cupping to happen. Now I'm exaggerating it here. But by having opposite direction grain, okay, so hang on, now I might have to go in the wrong direction. Hang on, I'm going to fix that because I'm not particularly happy. Let's try this again. All right. So what is cupping? First of all, let's go back to that. Let's go back to basics. Cupping is when the timber dries out. In some areas, the timber dries out faster than others. The annual rings tend to kind of sort of straighten out. So for example, this board here, what happens to it? If it cupped, it would go in this direction. Why? Well, the grain that is on it, that annual rings will have changed, and parts of it will have pulled in. But if I look at the board beside it, so if we go for this board, what would happen to that one? It would go in the opposite direction. And again, my grain will go something like that. But by putting them side by side, you are counteracting that effect. So we get a much straighter board. And those boards, by the way, will only be between 12 and 25 millimeters. So there won't be a terrible amount of that happening anyway. But even still, it'll keep it balanced. All right. Faced with veneers is a key word there, or a key phrase. That's important. Other than that, no, we're okay. Oh yeah, well, it's important too to note that when the facing veneer is put on, the grain of the facing veneer is at a different angle, or at least it is at 90 degrees to the grain of the blocks. So if we look at it there, there's my block grain. Let me try it again, sorry. Sometimes it's easier to draw on this, sometimes it's awkward. It's awkward to draw when you're talking. Okay, so it's going in that direction up there and that direction there. All right, so that's Blockboard. Moving on, we're into pine board or lamb-wood. Pine board, we call it. You're used to seeing it in school. We use it a hell of a lot. It's very handy. It's very easy to cut. It's easy to move, or easy to work with, and it won't bend, it won't warp, it won't twist. So what is it made from? And we'll go with the keywords again. It's thin softwood strips, pine, that's what it says in the tin, glued together. And what does it do? It gives us this nice wide board in softwood. Okay, we don't have the pretty veneer facing, but we don't need it. It's a nice uniform thickness. So uniform thickness would be a key phrase, generally between 12 and 25 millimeters. 25 millimeters being an inch, or well, close to an inch, what we would have considered an inch. The boards can cup over time, particularly if they're stacked incorrectly or stored incorrectly. Very useful for projects because it gives us nice tabletops, large sheets to be used, and yet we can still joint it. You can get hardwood examples. Why we like it so much, and this I suppose is the important bit, can be used for jointing. So you can still put joints into this, where you can't really, well, I was going to say you can't use plywood for joints. You kind of can, but in general you wouldn't. All right, so that's pine board or lamb wood. Next one is OSB, oriented strand board. Again, You might be asked, what does OSB stand for? Oriented Strand Board. Okay, what is it? It's like wood flakes or strands, and they're bonded with resins into a strong board. So you'll have seen these kind of boards different places. It's basically glued, or well, resins are used to compact and push these flakes into a nice flat and even board. They're arranged so that they don't overlap. Or sorry, what am I talking about? The strands are arranged so that they overlap, hence the oriented, right? So they're turned so that they're constantly overlapping, and that's what makes it stronger. Okay, and again, we get nice standard sheet sizes used for flooring and construction. Okay, it's used a lot in those areas. Flooring construction is where you'd use it, roofing, under a felt roof, for example. The big thing with it is that the strands are overlapped. That is very important, and that's what makes it slightly different. So OSB, oriented strand board. Moving on, then they're just showing you how OSB is put together. All of this, by the way, is in your textbook. So you can see it there. The logs are debarked. Okay, so stripped of their bark. Okay, then they're cut up and stranded into strands. They're then soaked and dried. The strands then are blended into these resins and laid into sheets and pressed into sheets. And you get this OSB board. Okay. Now, chipboard is our next one. Chipboard, sometimes you'd mix up with OSB. They're very, very similar. The difference here is that this oriented stuff isn't happening. It's not quite the same. So the wood chips are glued, they're pressed into sheets, they're faced with wood, veneer, or plastic laminate, and the edges of the board need to be covered. Where you'll come across this a lot is this bit here, often faced with wood, veneer, or plastic laminate. Kitchen countertops, not so much in recent years, but certainly in the 70s and 80s in Ireland. And I suppose if you haven't a terrible load of money to spend in the kitchen, the countertops were often made with chipboard. And it was faced with this plastic laminate. So facing means that it's just covered on it to make it look a bit better. The problem with chipboard, though, is if you are doing something like that, you need to cover the edges. But more importantly, if it gets wet at all, it tends to soak up the moisture and it swells. And hence why those kitchen countertops would have been relatively inexpensive, because they wouldn't necessarily have lasted the longest. So if you look over here again and how it's made, the wood is processed into particles, into little bits. That's then mixed with an adhesive. It's spread out and pressed with heat. And then your finishes boards would be sanded and cut to shape. Okay, so similar to OSB, the difference is in OSB, they try to organize the strands so that they are all overlapping. In chipboard, it's more of hodgepodge and mix them, gathering, of pieces. How would you cover chipboard? Well, there's a few different ways. You can use an iron-on veneer, which is literally, it's like sellotape in the sense that it comes in a roll. It actually looks like a roll of masking tape, but on the back of it, it has a glue that will only adhere when it's heated up. So you'd lay the iron-on veneer along the edge of the timber. You'd literally put an iron up against it. It heats the glue, it melts the glue, and allows it to stick. And you end up with a covering like this. Or sometimes they will pin or glue on a solid edge, depending on what it's to be used for. And obviously those different methods will change the cost of your chipboard as well as you go. All right, MDF, very, very popular board material. And again, look, this is one of these. Okay, what does MDF stand for? Things medium density fiberboard. Okay, MDF. What is good about it? Well, it's a very popular board material. Why? Because it's quite cheap and it's quite easy to work with. To be honest, it's not really like working with wood, it's like working with simple material. Again, often faced with veneer or sometimes, again, plastic laminate. Now, it's made with very, very fine wood fibers, okay? And those wood fibers are laid generally in 3 layers. The problem with it, though, is that you would need to drill into it before nails or screws are inserted. And sometimes the nails and screws may not last terribly long in it. Also, and this is a major one, the fine dust is quite harmful, to the point where we have more or less stopped using it in schools, only sometimes. Whereas in the kind of 80s, 90s, it was a majorly useful material, and it was being used in every school. But not so much anymore, because it does, when you cut it, because it is literally pieces of dust, look, pushed and compressed together. You can see that in the picture. When you cut it, that dust also rises as you cut it, and not quite the same as the sort of dust you get from normal timber. It is a fine, almost a mist dust. You'd hardly see it. Hardboard. Now, hardboard is what we would have used on your folders in first year. So you're well used to it. It's usually about 6 millimeters thick. You can get heavier sides, all right, but generally it's about it. What is so suitable about hardboard is that it's available in nice thin sheets, which is what we're after. One face of it is smooth and one is textured, one is rough. Sometimes you can find it faced with a plastic laminate, again, so similar to chipboard. You can put a plastic laminate on it and make it look prettier. Often used in the back of cabinets or the base of drawers. Because it's so light, it doesn't need to be terribly structural. It's just really there to stop, well, stuff falling out of the drawers really, and stuff, and being able to put the cabinet up against a wall where it won't be seen anyway. It's only used indoors. It's not suitable for the weather. It is, what isn't written there is that it's very easy to cut. You'd cut it with a Stanley knife, relatively easy, and it goes through a saw nice and easy as well, although it can often leave a very rough finish if you cut it by hand. So that's hardboard. Now, what sheet sizes in general are available to both to buy and in our own school? So in general, you will find 4 millimeters, 6 millimeters. We have a hell of a lot of 6 millimeters in school, 9, 12, 15, 18, and sometimes 25. Okay, so they are our sheet sizes. And look, the rest of that then is just some questions on manufactured boards. I'm just going to look at this one here for a minute, where it says 3 layers of wood have been glued to make plywood. Draw a sketch to show the direction of each layer. The reason I've stopped on this is I gave you this question in the summer, or was it Christmas test? It was one of the tests there lately anyway. And I asked you to draw arrows to show me the direction it was going in, and I don't think I said the word arrow, so I said something like show how the sheets would be arranged. This is what I was after. I wanted you to come along and show me that, look, this would be going in this direction, this would be going in this direction, and this would go opposite again. And then that the top and bottom are the same. That's kind of what I was getting at there. So just watch for that question. Comes up a lot. Here they are. Look, they're asking you to draw a sketch to show how the ends are covered. That's fine. Oh, sorry. That's fine. We know how to do that. We saw it there in the sheet. Now, this is important because it wasn't really mentioned. Actually, it was, sorry, but there's a few extra ones here. Advantages of manufactured boards. We already said the large sheet sizes, very important. We can cover large areas quickly. They have a uniform thickness, important. They're very stable, no shrinkage. Stable, by the way, is a key word. They do not warp. They help us use wood efficiently. There's no waste or very little waste, and often veneered over to help us have more expensive looking timber without actually expensive timber. Okay, WBP, water and boil proof. What do the letters WBP stand for? Why are manufactured boards sustainable? They are an alternative to solid wood. They help reduce the impact of tropical forests, and they reduce the waste of wood by using waste timber and forest thinnings. And that's us back to the end. All right, so what I want you to do with that is take away some of that information I mentioned. I am assigning you a question, and I would like you to submit your answer to me. And that will be it then for today's lesson. All right, guys, thank you very much.